The summer of 1948 arrived with unusual warmth across the chalky fields of East Sussex. A farmer named Edmund Hartley was preparing his land for the autumn planting season, working the same corner of his property he'd farmed for 30 years before the war interrupted his rhythm. The soil here had been compacted during the fighting, marked as cleared by the Royal Engineers, yet Edmund knew to remain cautious. He moved methodically with a hand plough, the old way his father had taught him, keeping the blade shallow to avoid deeper disturbance. By mid-afternoon, with the sun already beginning its descent, the plough caught on something solid, not stone, something metallic that rang against steel. Edmund stopped, his hand moved to the tool, then froze. He called for his son to fetch the police. What he'd found, half buried in that Sussex earth, undisturbed for 3 years, was a British No. 7 anti-personnel mine, its acid green paint still faintly visible beneath the soil. The explosive compound inside remained volatile, still capable of launching metal fragments through a man's leg with the force of a shotgun blast. This moment, played out quietly on a summer afternoon far from any battlefield, captures something crucial about the mines Britain developed and scattered across Europe in the Second World War. These weapons were designed to kill in a moment of intense combat, yet many continued their lethal work decades afterward, turning farmland into a minefield, roads into death traps, and peace into something far less certain than victory should have offered. The anti-personnel mine would become one of the war's most enduring and troublesome legacies, a technology born of desperate necessity that would continue to demand respect and fear long after the fighting ceased. The Britain of early 1940 faced a strategic problem that seemed to have no adequate solution. Having lost the vast majority of its heavy equipment and vehicles at Dunkirk, the nation now confronted the very real possibility of German invasion. The coastlines of southern England represented the most obvious invasion route, yet the British Army possessed only limited means to defend them. Concrete pillboxes were being constructed at a frantic pace, but they required soldiers to man them. Anti-tank obstacles cluttered the beaches, scaffolding, dragon's teeth, concrete blocks, yet these served little purpose if defending forces lacked the training or numbers to defend them effectively. The emerging doctrine required something that could kill enemy soldiers indiscriminately, without requiring defenders to be present. Something that would force an invading force to move slowly, to probe carefully, to lose men and momentum simply by advancing across any piece of terrain. The solution, when it finally emerged from the military's desperation, came in the form of the anti-personnel mine. Unlike anti-tank mines, which required significant pressure to detonate and thus served to disable vehicles, anti-personnel mines were designed to be lethal to individual soldiers. They needed to function reliably when a man stepped upon them with his full body weight, around 80 kilograms concentrated on a single boot. Germany had employed such mines since the early days of the Russian campaign, and the concept was hardly revolutionary. However, the British needed to produce them rapidly, deploy them extensively, and design them to be reliable in the damp and variable climate of a potential invasion landscape. The Royal Ordnance factories and various defense establishments began work with an intensity born of genuine fear. If invasion came, these mines might be all that stood between occupation and survival. The scale of the challenge was immense. Estimates suggested that defending the British coastline adequately would require hundreds of thousands of such devices. This was not a problem of invention, it was a problem of industrial capacity, reliability, and strategic deployment. Every mine that failed to function represented both a waste of resources and a potential gap in a defensive line. The technical solution emerged from the cooperation between the Royal Ordnance Factory at Bridgewater in Somerset and the research facilities at Fort Halstead, near Sevenoaks in Kent. The resulting design, standardized as the No. 7 anti-personnel mine, represented a triumph of British engineering efficiency. The mine itself was a relatively simple device by modern standards, though its operation depended upon a series of carefully calibrated mechanical and chemical tolerances. The casing was cast iron, painted a distinctive acid green that was intended to make the mines visible to defenders, though this color faded quickly to an inconspicuous brown-green once they'd been in the ground for a few months. The body measured roughly 12 centimeters in diameter and stood perhaps 7 centimeters in height, resembling nothing so much as a small metal biscuit tin. Inside this modest container sat approximately 200 grams of trinitrotoluene, more commonly known as TNT, which is the principal explosive compound. The genius of the design lay not in the explosive itself, but in the fusing mechanism. A spring-loaded pressure plate sat atop the mine's body, requiring a force of between 6 and 8 kilograms to depress fully. Beneath this plate sat a simple but robust mechanical fuse assembly. When downward pressure was applied, the weight of a man's boot stepping directly upon the mine, this fuse would complete an electrical circuit. A small firing pin would strike a percussion cap, which in turn would ignite a small amount of detonating powder. This detonator would then reliably initiate the main TNT charge. The entire sequence took place in a fraction of a second, and the resulting explosion would project the mine's cast iron casing fragments in all directions with tremendous velocity, typically causing catastrophic injury to anyone within a 2-meter radius and potentially inflicting wounds at distances up to 6 meters away. Manufacturing these devices required extraordinary precision. The pressure plate had to be calibrated so that it would not detonate under the weight of a tank, where the pressure per square centimeter would be far greater, yet would reliably function when a soldier stepped upon it. The fuse assembly required hand assembly by skilled workers, many of them women, working in conditions where a single mistake could prove fatal. At the height of production, British factories were manufacturing something on the order of 200,000 to 250,000 anti-personnel mines per month. The components were produced at multiple locations, then assembled at dedicated factory facilities. By the war's end, Britain had manufactured nearly 2 million No. 7 mines, making it one of the most widely produced anti-personnel weapons of the entire conflict. Transport and storage presented their own challenges. Mines were boxed in cartons of 50, packed with straw for cushioning, and distributed through naval depots and army storage facilities. They had to be stable enough to survive being stacked and handled, yet sensitive enough to function reliably when required. The chemical composition of the explosives had to resist moisture, temperature fluctuation, and the simple degradation that came from months or years of storage in damp climates. The operational deployment of British anti-personnel mines began in earnest in 1940, as Operation Sea Lion appeared to be a genuine threat. Millions of mines were distributed to coastal defense units with instructions for laying them in defensive patterns. The beaches and estuaries of the south coast received the heaviest concentration, with specially trained sappers laying mines in carefully marked fields. However, as the invasion threat receded and the war shifted to the offensive, the mines found new purpose. When British and American forces landed in North Africa in November 1942, large quantities of anti-personnel mines were shipped alongside the heavier anti-tank ordnance. British mine layers found themselves laying mines across the deserts of Libya and Egypt, not to defend a position, but to protect newly captured territory from counterattack. The mines served a crucial function in slowing the recovery time that German forces required to mount new offensives. In the Mediterranean theater, mines were deployed around staging areas, ammunition dumps, and temporary airfields. They created zones of controlled space where movement required either time-consuming clearance operations or dangerous speed and vigilance. By 1943, as British forces geared up for the invasion of Sicily and then mainland Italy, anti-personnel mines became central to the occupation and consolidation of newly captured territory. The pattern was remarkably consistent across all theaters of war. Within days of capturing ground, British engineers would establish forward minefields, laying the No. 7 in patterns designed to force any counterattacking force into narrow corridors where they could be met with concentrated fire. The psychological impact upon German and Italian forces was considerable. These were not battlefield casualties happening in moments of intense combat. They were soldiers being wounded while moving cautiously through allegedly secured territory, or during prisoner processing, or whilst simply moving supplies. The psychological cost of knowing that at any moment your boot might strike an anti-personnel mine created a constant, wearing strain. If you are finding this interesting, a quick subscribe helps more than you know. It means the algorithm knows this sort of content matters to you, and there's an awful lot more of it to come. Comparing the British anti-personnel mine with its German equivalent reveals both similarities and crucial differences in design philosophy. The German S-mine, also known informally as the Bouncing Betty, functioned on an entirely different principle. The S-mine sat in the ground until its pressure plate was activated, at which point it would catapult itself approximately 1 meter into the air before detonating, thereby spraying shrapnel across a wider area. This design made it far more effective in open terrain, where it could inflict casualties across a larger radius. However, the S-mine was also far more complex mechanically, requiring more careful assembly and more stringent storage conditions. The British No. 7, by contrast, was deliberately simple. It detonated at ground level, meaning its lethal radius was narrower but far more predictable. The American approach, embodied in the M1 anti-personnel mine, was similar to the British design but slightly larger and requiring greater pressure to detonate. The Americans produced roughly the same overall quantity of anti-personnel mines as the British, though their distribution patterns differed significantly. American mines tended to be deployed in greater concentrations in specific defensive positions, whereas British doctrine favored wider dispersal across larger areas. The British mines proved cheaper to manufacture than their American counterparts, roughly half the cost in terms of raw materials and labor, which partially explains the higher production volumes. In terms of actual combat effectiveness, the differences were far less significant than their designers might have hoped. All three designs killed and wounded indiscriminately. All three required careful clearance operations. The post-war analysis of mine casualties across different theaters suggested that no single design demonstrated a dramatic advantage in terms of reducing enemy offensive capability. The S-mine's superior fragmentation pattern was offset by its mechanical complexity and greater sensitivity to moisture and temperature variation. The British simplicity of design proved an advantage primarily in situations where reliable function mattered more than maximum blast radius, which is to say, nearly all of them. The actual historical impact of anti-personnel mines during the Second World War remains difficult to quantify with certainty, partly because records were not maintained consistently, and partly because the psychological effect of mines often exceeded their material casualty-producing effect. The German military's own estimates, compiled in post-war interviews, suggested that anti-personnel mines accounted for between 5 and 10% of total casualties on the major battlefields where they were deployed in significant numbers. In the Western Desert Campaign between 1942 and 1943, where both sides employed extensive minefields, the percentage was somewhat higher. Estimates suggest that mines accounted for perhaps 12% of British casualties and a similar proportion of German losses. However, this statistical measure misses something crucial. Mines force the commitment of enormous resources to clearance operations. Sappers with prodders and probes had to move painstakingly through minefields, a process that was not only slow but psychologically grueling. The knowledge that at any moment one might trigger an explosion created a tension that no soldier could maintain for extended periods. Divisions clearing minefields of significant size required rotation of personnel every few hours simply to maintain alertness and prevent mistakes born of fatigue. This represented an enormous commitment of manpower at a time when such resources were scarcely available. Furthermore, mines continued their work long after battlefields had been officially abandoned. The armistice in North Africa left approximately 750,000 anti-personnel mines scattered across the desert. When the area was eventually thoroughly cleared, some 18 months after the fighting had ceased, it was discovered that many of these mines had undergone minimal degradation in the arid climate. They were as lethal when cleared in 1944 as they had been when laid in 1942. The psychological impact persisted, too. Italian civilians returning to their homes in areas that had been fought over multiple times found themselves living in territory where almost any disturbance of the ground might prove fatal. Reports from the period describe farmers plowing fields cautiously, construction workers probing before digging, and considerable loss of life amongst civilians who simply did not possess the expertise to navigate mined terrain. The legacy of these mines extended well into the 1950s in many regions, particularly in North Africa and Southern Europe. The lasting legacy of the British anti-personnel mine demonstrates how weapons designed for immediate tactical advantage can create problems that persist across decades. Unlike aircraft or artillery pieces, which became obsolete with the development of newer technology, anti-personnel mines retained their lethal potential indefinitely. They required no fuel, no maintenance, and no special storage conditions beyond basic protection from the weather. A mine buried in 1943 was potentially just as dangerous in 1953 or 1963, or even 1973. This indefinite lethality became increasingly recognized as a humanitarian problem during the post-war period. By the 1960s, international military communities began to acknowledge that whilst anti-personnel mines served a legitimate defensive purpose, their long-term consequences were profound. The Convention on Certain Conventional Weapons, eventually signed in 1980 and amended several times thereafter, placed restrictions on anti-personnel mine usage. Britain itself was a driving force behind these restrictions, perhaps recognizing that it had produced nearly 2 million of these devices and was now confronting their consequences. Today, surviving No. 7 mines occasionally emerge from the soil of Sussex and Devon farmland, or are discovered during construction work in the Mediterranean. Museums, including the Royal Artillery Museum and the Imperial War Museum, maintain examples of these devices to educate visitors about their design and impact. The technology itself became the template for many later anti-personnel mines designed by other nations, though most incorporated marginal improvements to the basic design. What marks the British anti-personnel mine as particularly significant is not that it was revolutionary. It was not, but that it was effective, reliable, and produced in sufficient quantity to alter the character of several theaters of war. It represented the problem-solving of a nation facing existential threat, designing and manufacturing a weapon system with remarkable speed. Return now to that Sussex field in the summer of 1948. Edmund Hartley, the farmer, did not attempt to remove or disarm the mine he discovered. He waited for the police, who called upon the military, who sent sappers trained in mine clearance. These specialists arrived with their prodders and their probes, the same tools their predecessors had used during the war itself, but now employed in peaceful circumstance. The mine was carefully excavated, its fuse examined, its explosive charge confirmed. It was then placed on a cart and transported to a designated demolition range, where it was detonated along with dozens of other forgotten mines recovered from the surrounding countryside during the first years of peace. This single incident, multiplied thousands of times across the territory Britain had fought over and defended, tells the story of the anti-personnel mine more vividly than any official casualty statistic. These weapons had served their purpose, slowing invasion, protecting newly captured territory, inflicting casualties that accumulated into meaningful strategic effect. Yet they had also created a different kind of battlefield, one that persisted after the soldiers departed. The chalky soil of Sussex and the sun-baked earth of North Africa both bore these scars for decades. The No. 7 anti-personnel mine was not the most sophisticated British weapon of the Second World War, nor the deadliest. It was not revolutionary in its design, but it was precisely the weapon that desperation demanded, simple, reliable, manufacturable in vast quantity, and deployable in patterns that could transform any piece of ground into contested space. That this same weapon continued to kill and wound civilians long after the war ended, forcing farmers to work cautiously and engineers to probe before building, represents the final and perhaps most important lesson about anti-personnel mines. The battlefield does not end when fighting ceases. The mines remain, generation after generation, waiting in the soil for the moment when carelessness or desperation brings boot or spade down upon them. In this way, the Second World War extended itself across decades, the consequences of choices made in the most desperate years reaching forward to touch civilians who had no part in the choices that had scattered these devices across the earth. Edmund Hartley found his mine, the mines were cleared, and the fields were eventually declared safe. Yet the knowledge that such dangers existed never quite departed from the consciousness of those who worked that land.